All right, so now before we actually start solving, we need to know the power property of equality, right? And that just means if I have an equation, right? If I have an equation of A equals B. Let me zoom in just a little bit here. If A equals B, right? That means I can raise both sides to the same power. So they raised A to the nth power, that's equal to B to the nth power. You just have to remember A is the entire side. So for example, on the left-hand side, let's say I had square root of x plus 2 is equal to 3, right? This entire thing, this entire left-hand side, right, would need to be squared, right? And this entire right-hand side needs to be squared. You can't square individual terms. So let's be very clear on that. So if you square both sides, just like we see down here, the square root and the square, right, they cancel each other out. So we have x plus 2 is equal to 3 squared is 9, right? Then we can solve for x by subtracting 2 to both sides. So we subtract 2 and we get x is equal to 7, right? And lastly, this is something that we do have to do that a lot of people forget to do, honestly. We have to check the solution to make sure that we didn't get an extraneous solution. Now, what do we mean by that? So whenever we multiply both sides of the equation with variables, right, by squaring or whatever, something called an extraneous solution can be created. So we have to check to see if that solution we got was a legitimate solution or not. So what do? We substitute x equals 7 back into the original, right? So we got, the original was x plus 2. A square root of x plus 2 equals 3. And we need to verify if this is true or not. So 7 plus 2 is 9, right? Square root of 9 is equal to 3. So 3 does, in fact, equal 3. So x equals 7 is a solution. Okay? So let's try the next problem. I'll give you a couple of minutes to work through this one. But remember, you're going to square both sides and then solve for x. Okay? Okay, so finally, get back up here. We have the square root of x minus 5 is equal to 4. And we have to square both sides, right? So we're going to square both sides. That way the radical is cleared and you have x minus 5 on the left-hand side. 4 squared is 16. So now we can add 5 to both sides, right? So x is equal to 21. So I'm going to write here, you must check your answer. Okay? Because if you don't, you might get an extraneous solution which is not a correct answer. And you get that wrong on the exam. Alright, so let's plug it back into this original equation. So I have the square root of 21 minus 5. Does this equal 4? Right? We need to check. So this is what? 16. Square root of 16. Does that equal 4? Yes. 4 is equal to 4 on both sides. It's correct. Therefore, it's a solution. Now I can circle this and say, yes, this is a solution. Okay? Alright, let's move on. Do some more. And as you can see here, I don't know why it does that sometimes. We have to solve the square root of 4x plus 5 plus 1 is equal to 0. Now this is an interesting problem. Now before you square both sides, right, we want to isolate the radical by itself on the left-hand side, right? Because if we square this entire left-hand side as is, it's going to be a complicated problem, right? You're not going to clear the radical basically. So you move the plus 1, you got to subtract 1 to both sides. Now this is where it gets interesting. Before I even square both sides, I'm going to ask you this. Is there the square root of any number, right? Can I get the square root of a number and get a negative as an answer? Because it's a square root, meaning it's something squared has to give me, so I'm not going to get a real solution, basically, right? It's not going to be, for example, if I did 1 squared, that's 1, right? 2 squared is 4. If I did negative 2 squared, right, don't I still get positive 4? So I already know that this is going to be a no solution situation here, but let's just continue on, okay? So we square both sides, right? And we get 4x plus 5 is equal to negative 1 times negative 1 is positive 1. Then we subtract 5 on both sides, right? So we get 4x is equal to 1 minus 5 is negative 4. To solve for x, we have to divide both sides by 4, and we get x is negative 1. Now when you substitute this in to check, we get, let me do it in a different color ink, we're going to get 4 times negative 1 plus 5 under the radical plus 1 equals 0. So we have to check this. This is what? Negative 4 plus 5, right? Negative 4 plus 5 is 1. Square root of 1 is still 1 plus 1 is equal to 2. 2 does not equal 0, right? You see that? So this is not a solution. So this is not a solution. That's an extraneous solution. Okay, so that was our first example of an extraneous solution. So this one we're going to work together again. As you can see here, right, we want the radical by itself, right? So we're going to isolate the radical. So I need to subtract this 2 to both sides. So now I get the square root of 3x minus 2 is equal to negative 2. So I know because this is a square root, right? A square root can never equal a negative number. This one has no solution, just like the previous problem, right? But for the sake of practice, let's just do it. So I'm going to square both sides. Remember, a negative number needs to have parentheses around it, right, when you square it. So I have 3x minus 2 is equal to positive 4, and we can add 2 to both sides. So now I have 3x is equal to positive 6. Then we divide by 3 on both sides, and we get x is equal to 2, right? And as you can clearly see, we need to plug it back in, right? Must check solution. All right, so let's see what happens here when we plug it back into the original, right? So make sure you plug it back into the original because, you know, this has to be true, right? So we have the square root of 3 times 2 minus 2, right? Plus 2, does this equal 0, right? So we have 6 minus 2 is 4. That's the square root of 4 plus 2. That's 2 plus 2 is 4 does not equal 0. So that means this is not a solution. Not a solution, right? So the answer here is no solution. Okay, I hope that is very clear for everyone. If you have a question, you're not quite understanding it, please ask in chat. I just realized that my notifications for chat don't appear right now. Hold on, let me change this back. Okay, there we go. Let's move on. Alright, are we all doing okay with these problems? There's not too many of these, so it shouldn't be too bad. Okay, so let's look at the next problem here. You will see that in this problem, the radical is already isolated, right? There's nothing else on the same side as this square root. So we can actually go ahead and square both sides, right? So as a quantity, you need parentheses when there's more than one term. So we square both sides here, right? And we get x plus 3 on the left-hand side, right? And if you remember, x plus 1 is a binomial squared. You can do x squared plus, right, 2 times x times 1 plus 1 squared, right? That gives you x squared plus 2x plus 1. That's the formula way, okay? So that's how we get this x squared plus 2x plus 1. Now, we want to see this is like a quadratic equation, right? So we want to set it equal to 0. So I'm going to subtract x on both sides and the 3 to both sides so that the left-hand side is equal to 0. So let's subtract x, and then subtract 3 and 3. So on the left-hand side we have 0 is equal to x squared plus x minus 2. At this point, I see that factoring might be an option, right? So remember from the previous chapter 6, right? We did a lot of factoring. This is all coming back, right? If you weren't good at factoring, I told you you're going to struggle with a lot of different problems, right? So we have 0 is equal to x plus 2, x minus 1, right? And then using our 0 factor rule, you can set each factor equal to 0, right? And solve for x. So we have two solutions. The first one is x is equal to negative 2, or x is equal to positive 1. And lastly, we must check solutions, because one or both of them may be extraneous, right? And if you get an extraneous solution, that means that's actually not a solution. So what we're going to do is plug in this negative 2 into the original. So negative 2 plus 3 is equal to negative 2 plus 1. Right? So this is 1. Square root of 1 is equal to 1. And on the right hand side, negative 2 plus 1 is negative 1. So you see how this is not equal, right? So the first one is not a solution. So I'm going to cross that out. I'm going to check the second one. The square root of 1 plus 3 is equal to 1 plus 1. So this is square root of 4 is equal to 2, and 2 is equal to 2. So the second one is a solution. X equals 1 is a solution. Okay? Everyone got that? You see the importance of checking these solutions. So please try the very next problem here. And at the end, check both solutions to see if it's extraneous or not. Just quickly recap. So I have to square both sides, right? So I get x minus 5 on the left-hand side. Right-hand side, I get x squared minus 14x plus 49. And because the x squared is positive on the right-hand side, I'm going to bring these the x minus 5 to the right. So I subtract x and add 5. So I have 0 on the left-hand side is equal to x squared minus 15x plus 54. And I see this quadratic is factorable, right? So the 54 is positive, but this 15 is negative. So I know this is going to be x a minus situation here, right? Minus 9, x minus 6, right? 9 times 6 is 54. But if they're both negative, they add up to a negative 15. Then you set each factor equal to 0, right? Using the 0 factor rule, and solve for x. So you get x is equal to 9, or x is equal to 6. And lastly, you must check solutions. You don't know how many people don't check at the end and get the problem wrong. So let's start off with the 9. We got 9 minus 5 as a square root is equal to 9 minus 7. So this is the square root of 4 is equal to 2, which is correct, right? 2 is equal to 2. So 9 is a solution. Now I'll move on to the 6. 6 minus 5, oh gosh, what happened there? 6 minus 5 under this radical is equal to 6 minus 7. And I could already see this is a negative, so it's wrong, right? This is wrong. 1 does not equal negative 1. So we have just one solution. X is equal to 9. Alright, glad some of you got that. Let us continue on. We may see examples like this where the final answer is a fraction. Okay, we have the square root of 7x plus 1 minus 1 equals 2x. So first we have to isolate the radical, right? That means this non-radical minus 1 needs to go to the other side. So plus 1 plus 1. So that we get the square root of 7x is equal to 2x and plus 1. Now that the radical is by itself, we can square both sides, right? And we get 7x plus 1. And 2x plus 1, when you square it, you get 4x squared plus 4x plus 1. And real quick, if you forgot the formula, it's a squared plus 2 times a times b plus b squared. So that's my 4x squared plus 4x plus 1. Okay, and that's the right hand side. Now the 4x squared is positive, so I will bring these terms to the right. So subtract 7x, subtract 1. So this left hand side is 0 is equal to 4x squared. 4x minus 7x is minus 3x. And then the 1's cancel out to 0. So this is not a trinomial, right? So I'm just going to look for the GCF, which is an x, right? So 0 is equal to x times 4x minus 3. And you set each factor equal to 0. So that means x is equal to 0, and 4x minus 3 is equal to 0. Remember this from chapter 6, right? So this one's okay. We need to do this. We have to add 3 and divide by 4. So x is equal to 3 over 4. So we have to check both solutions to see if they're actual solutions or not, right? So check. Let's start with the 0 because that's easier. So 7 times 0 plus 1 as a radical, and then minus 1 equals 2 times 0. So this right here is 8, right? I'm sorry, 1. 1. Square root of 1 minus 1 equals 0. 1 minus 1 equals 0. 0 equals 0. So that one's a solution. Now let's check the next one. We have 7 times 3/4 plus 1, and this is under the radical, minus 1 equals 2 times 3/4. So this is 21 over 4 plus 1. 1 is 4 over 4, right? That's an easy way to put it. And this comes out to 3 over 2. So this is 25 over 4. Square root of 25 over 4 minus 1 equals 3/2. So what is square root of 25 over 4? We learned this in this current chapter, right? We can split these up. We get the square root of 25 over the square root of 4, right? Is equal to 5 over 2. So now we have 5 over 2 minus 1. What is 1? 1 is 2 over 2, which is equal to 3 over 2. So this actually works as well, right? So both are solutions. Or actually, I could circle the ones we wrote here. Okay, so that one was probably a tougher one because of the challenge of dealing with fractions. Okay. Okay, that was just to check. So here is your problem. Let me see here. Yeah, we have couple left. So here you go. I want you to try this on your own. But I'm not sure if everyone is finished. Why don't we just take a look at it together and see how we're doing. So the first thing I noticed, this -1, right? So if I want to isolate the radical, I need to move this -1 to the other side. I want to move it, so I add 1 to both sides. So I have the square root of 5x plus 1 is equal to 3x plus 1. Next, I can square both sides, right? And when I square both sides, I get 5x plus 1 on the left-hand side, and I'm going to get 9x squared plus 6x plus 1 on the right-hand side. Now, does everyone know how I got that? If you forgot, the formula is 3x squared plus 2 times a times b, right, plus b squared, right? That's your 9x squared plus 6x plus 1. All right, so I see 9x squared. This is a quadratic, right? So I'm going to move the 5x plus 1 to the left-hand side. So I got 9x squared, and then 6x minus 5x is plus x, and 1 minus 1 is 0. So it's just 9x squared plus x. And I factor the GCF of an x out, and I get 9x plus 1. So how many people got up to this point right here? So this is 9x equals negative 1. So how many people got up to this point? X equals 0 and x equals negative 1/9. Oh. So before we continue, where did you, what errors were made? Did you get up to the factors? Okay. Well, then you know, yeah, you'll know what to do next then, right? Because now that you see the steps, right, you're gonna have to work on these individual steps here. Okay. Let's check the solutions, right? Must check. Otherwise, we won't know what our actual solutions are. So I have 5 times 0 plus 1 under the radical minus 1 is equal to 3 times 0. So this is 0 plus 1 is 1, right? Radical 1 minus 1 equals 0. 1 minus 1 equals 0. 0 equals 0. So that one works. Now let's try the next one. So the next one is 5 times negative 1/9. And then we have plus 1, and this is all under the radical. Minus 1 is equal to 3 times negative 1/9. So you all have your calculators, right? Your calculators should be able to do this. So you can just do the left-hand side and then do the right-hand side separately and see if they match up, right? But if they don't, you would have to do it by hand, like this. So this becomes 4/9. So square root of 4/9 minus 1. This is equal to 2/3 minus 3/3 is equal to negative 1/3. So this is correct as well. So we have two solutions. We have these two as actual solutions.